You know the word queue, right? Whenever you're in a line, you're waiting for a person to go so you can be attended by whatever or whomever you want to be attended by. Let's say you want to go to McDonald's and there's 3 people ahead of you. Then, this is you, waiting for your Big Mac and your big milkshake, that's strawberry or maybe chocolate. You have to wait for each of these persons to go out of the queue. So you wait once, you wait twice, you wait 3 times. And then, after this part of the queue has gone through, it's your turn to get your Big Mac and whatever you want. But for stacks, it's the other way around. For stacks, we follow the convention last in, first out, which means you get in at last, and no one gets ahead of you. No one gets added to the stack after you. So, whenever we pop, meaning we get the item from the stack, we won't get it from the front as within the queue, where you would have to wait 1, 2, 3, n amount of times until you are out of the queue, until you are popped out of the queue. The queues follow first in, first out, or FIFO, while the stacks follow the opposite. Last in, first out, meaning whenever we pop an item, we pop it from the top or from the end. In this case, you would be the first client to get your Big Mac, but this guy, the guy that arrived first, would be the last. It could take decades, years, millennia, whatever. Just remember, stacks, last in, first out. You pop from the end of the line. And queues, first in, first out, you pop from the front of the line. Hash maps or dictionaries, however you want to call them, they work the same way. They have a key, and they have a value. That's it, right? Well, it's like a regular dictionary. Let's say you have a dictionary that goes from a word in English to a word in Spanish. The word in English would be the key, and the words in Spanish would be the value. Let's say this is the word, probability. This is the value, probabilidad. Then, you access your dictionary this way. The name of your dictionary, just let me change the marker color. Dict, and your key. This way, you will get whatever value is associated with your key. In this case, if you did dict, this is the name of your dictionary whenever you define the variable of probability will give you its value. The big thing to remember with these guys is that they're really efficient, but they take a lot of memory. So you have to compromise one thing for others, you know? You want a great big O, but you don't want to waste memory. It's up to you how you decide and write your code. One thing to keep in mind about dictionaries or hash maps is their time complexity. Best case scenario when you want to insert or delete will be big O of 1. But worst case scenario, if the hash function behind the scenes doesn't work the way it's supposed to do, you would get big O of n. Next guys, we're gonna talk about sets. Sets are really simple to explain. They're things inside curly braces and they cannot have members that are the same. For example, you have a set, you define a set that has 1, 1, 2, 4, 4, 6. What the set will do, it will give you a resulting set that will only have one instance for each member. It doesn't have duplicates. Remember, no dubs. So, this set, when you define it, you will get this set. It will remove a 1 and a 4 because they don't like duplicates. They are really useful when you want to check members. For example, if you want to see if a user is in this usernames set, you will just have to do a big O of 1, a constant time complexity. Because remember, sets are really useful to check for membership. The next thing that's really important and hard to understand for all programmers are graphs. Graphs, these things are graphs and I don't like them. They're really hard to learn, but they're really useful when you code. Graphs are like linked lists in a way. They work with nodes, and each node points to the next node down the line. You can have, as I mentioned, binary trees, or trees that are not binary or balanced. But what you can also have are called heaps. Heaps are other types of graphs, as trees are. The main difference is that a heap, you can have a min heap and a max heap. That the main node, the base node, this is called the head, though. The head or the root node. How do you define which is the head or the root node? It's not that hard. Whichever node doesn't have a parent, that's the head or the root node. And all the numbers down the line, all the nodes down the line can either be max or min values, but the order will not matter. If you get lost during this video in any part, don't forget to send me a DM on Instagram, which is at AlbertJBlack. Just send me a DM and say, hey Pepe, I want to know more about whatever you want to know more, and I'll gladly explain it to you. Don't forget that today we went about data structures and how each of them has their own use and their own particular big O complexity for specific actions, whether it's insertion or deletion. Big O is just a capital letter O. That refers to the amount of time your code takes to run based on the number of items you have. If you like this video and you enjoyed it, don't forget to subscribe, hit the like button, and comment down below what you would like to learn. Peace out guys, take care.